Hi, good morning, guys. Hello, are you hearing my voice? Hello, good morning. Hello, are you audible with my voice? Uh, Hello, are you audible with my voice? Is it
Yes, Asif,
is it okay, correct?
we can hear you. Yeah.
Yeah, okay, okay. Thanks. Okay, good morning, all. Thanks for joining. Let us start. We have actually like 40 minutes session. So uh, I appreciated you all. Thanks for joining. Today I would like to discuss about you regarding the electrical design calculation. So this is our agenda today. S- in order to design our electrical system distribution boards or SMDBs or final DBs, we have to be uh, need to select breaker selection, cable selection, load schedule preparation. Today I like to discuss only these 3 points. Let me see how much I can cover these topics. Okay. So as I discussed like a webinar one, electrical design process involves you need to know the load, then wire cable sizes, breakers, DBs, SMDB, MDB transformer. This, if you know this, all the 7 points, you can design any electrical system easily. This is the basic fundamental. Okay. Now let us go to in detail. So as I said, I discussed today about how to calculate the cable, then breaker sizes. Let's see. We all know as there is a supply to the load, we need a cable to transmit our electrical current. This one till the date, and we doesn't get any wireless communication system, wireless transmission. Only less voltage. Only we got this one till the date. Hope so. It will become in future. We don't know. So as I said here, what is the parameters we have to be know? One is the power, and second we need to know cable, then load, voltage, current. This is the main five important parameters to design the cable or circuit breakers. Let us see. This I'm discussing about an UAE regulation as per the BSEN 50160 standards. The voltage regulation, like this is all we can say that UK standards. Yeah, as per the UK standards, we have our voltage, single phase voltage 230 volts and three phase voltage 400 volts, and frequency is 50 Hz. So we have a tolerance there. Like Abu Dhabi, its tolerance is -6% to 10%. Then it will become 216.2 volts to 253 volts. This is the tolerance we have. We know the voltage right now as per the regulations, as per the local authority, as per the standards. The voltage, what is the voltage? Few areas they use 240 volts, few 230 volts, some areas 220 volts. It have a tolerance, but as per the UK BSEN 50160 standards, the voltage is 230 volts, and the three phase voltage 400 volts, and few have 400, few have 400 volts, three phase. So let us go to the next session. We have we have to be calculate the our current calculations. To calculate the current calculations, we need to know three parameters. How we have to be calculated the what are the parameters? Let us see. If there is three notations are there. If you notice this one, IC and IC and IN See, this is the IC. IC means circuit load current. I mean, circuit load current means it's a load current. This we need to calculate. Let us go in detail. I just explain you the parameters. Once these parameters we know familiarize, then we go in detail. And what is IN? IN is a protective device nominal current rating. It is nothing but breaker current. I mean, what is a breaker current? This is called IN. Then we have a ID. ID means current carrying capacity of the circuit conductors. It means how much cable withstand the current. It is called that current called the ID. How this three relation is, we have circuit load current less than or equal to protective device current less than or equal to ID. It's if you can write in reverse way, then cable current, I'm telling you the like sequence. Cable current is greater than the circuit breaker current, then greater than the load current. So IC is a load current. This value, I mean, we have a I give you example so that you can understand this one. Then uh, let us go to the next slide. So cable selection, we have not only depend upon the only load current, as well as there are other parameters which will decide the cable sizing calculation. We are here, we need to know the load and what is the voltage drop, what is the ambient temperature, and installation methods. It's installed in the air, it's installed in the ground, or what. These are the four important parameters. Based upon that, we can calculate the cable. So as per there is a country to country different standards there, but in general, any basic IEC standards, we use generally 4% to 6%. 4% voltage drop is we need to consider. So we go in detail now. Cable size calculation, I give you one example. Let us assume we have a load is 4 kilowatt and our power factor is 0.8. This is a single phase. Okay, then we all know power is equal to VI cos pi for single phase. Then what is the I if we can write the I formula, current is equal to, this is nothing but the load current, that is equal to P by V into cos pi. Therefore IC is equal to the current equal to 4 into 1000. Okay, 4 kilowatts means 4 into 1000, 4000 watts divided by 230. Voltage is 230 and cos pi is I consider as 0.5. So it is the current rating coming 21.79 ampere. This is called the load current. This what we have. Then for this one we have to be select the breaker size. For breaker size, next rating is, what is the next rating we have to be select. We have like 6 ampere, 10 ampere, 16 ampere, 20 ampere, 32 ampere, 40 ampere. There are the breaker standard sizes are available. Based upon these breakers, based upon these breaker charts, we have to be select our cable, sorry, a circuit breaker. So the circuit breaker current rating should be 32 amperes. Now we come to know that we know the load current, then we know the circuit breaker current. What we need? We need now cable current. What is the cable current? Let us see. Then the cable current, there is, as per the ADDC standards, cable current should be 1.15 times the breaker size. So based upon that ID 1.15 based upon 32, it will come to 36.8 amperes. So as per the international standards, how we can calculate the ID, the BS 7671 standards states that there is a grouping factor required uh, in order to calculate the cable current. Then ID, the cable current, it's equal to IN. IN is a circuit breaker size, circuit breaker current divided by grouping factor. Grouping factor, I have a table. I have a table. I can give you the table. Based upon the table, we consider 32 point divided by 0.8. It is equal to 37.64. See, as per the ADD standards and this one, the cable current almost are it's almost near. Now we again I'm explaining you. We have a load 4 kilowatts, power factor zero point 0.8. Based upon this one, we calculate the load current. We'll get the load current. Once we got the load current, we will select our breaker size. The breaker size we know. Based upon the breaker size, we put the as a per standards or grouping factor. We will get the load current. Now we have to be check this 37.64 ampere. What is the cable size? And this we come to know from the cable chart only. Okay, this is the I have a cable chart. This is I collected from the DoCap cable charts. There is a various cables manufacturers there. For as we know, UAE DoCap there, and Riyadh cable there, and National cable there. There is a different uh, the group. There is a factors there. Now see, based upon what is our load current, 37 ampere something coming. So 37 ampere next rating, it will be goes to the 6 milliampere current. You see, this is a single phase cable, two cable single phase, AC or DC, and this is a three phase cable. We our calculation on single phase, so two cables, we calculated the cable current 37 amperes. So we can choose nearest cable size is 6 milliampere. So now again we go back to our calculation chart. Based upon this one, based upon the based upon the our calculation, we got the cable size as 6 milliamp 6 mm 6 square cable we need. But this is not enough to be calculated the cable. Then next step, we have to be calculate voltage drop. If voltage drop is meet the criteria, then our cable is safe. Let us see. Then how can we check the voltage drop? We have a formula. Voltage drop is equal to mv into I into L divided by 1000. So where what is MV? This is the cable voltage drop. Each cable, we all know each cable is made up of what? Conductor. Conductor, copper or aluminum. Mostly we use the copper conductors. Copper conductor have conductor have its have own resistance and its own inductance. So when we have a length of meter, for example, L length, X length have X length have a cable, it have its own drop. When we example say we will consider 10 volts, when it will be sending end voltage 10 volts, receiving end voltage, it should not be 10 volts, it have a drop. You all know, based upon the, it have resistance, it have inductance, it will, there is a drop. So we have a cable, its own drop, it is called MV. This own cable drop calculations given by the their cable companies. This value we can know from their table. Then we have a I equals to load current. Then we have L is equal to length of cable. These three we know. Then we can get voltage drop. According to the regulation, what is the voltage drop? Voltage drop should be less than 4%. Then now calculate VD, we can get 230 volts VD into 230 volts of 4%. How much will come? 230 into 4 by 100. It is coming 9.2 volts. So our voltage drop, if we calculated voltage drop 9.2 volts, if less than this one, our cable is okay. If it is not okay, we have to be selected higher rating of cable. Let us see. Load, we have 4 kilowatt. We have a current. This is, we have to take the load current. Load current 21.79 amperes. Then length, I consider 80 meter length. You can consider as much as you can. Let us see as per the where you are located. Then we consider, I calculated VD is equal to 9.2 volts, 4%. So next I will check the MV value. I will get the MV value from chart. I will show you the chart. MV value, I get the chart 7.3 into load current 21.79, and then length 80 by 1000. I'll get the 12.72 volts. So based upon my calculation, if I selected the cable 6 mm square, I got the voltage drop 12.72, which is not accepted by the authority. So what I have to be do? I have to be go to the next size cable. So let us see. Next size I'm going 10 mm, 10 mm square. So what is the MV value for 10 mm? 4.4 volts. Where I get this MV value? I get uh, from the cable chart. So 9.2, it is equal to 4.4 into 21.79. This is the current, and then 80 is the length by 1000. I'll get the 7.667 volts. Therefore, my my load, I have a 4 kilowatt load. For 4 kilowatt load, I select the cable size as 10 mm square. This is, and what is the breaker size? Again, we go back to, let us see, let us see. For I have a 4 kilowatt load, 4 kilowatt load. I have my breaker size is 32 amperes. I have to be selected 10 10 mm, 10 square mm cable. This is the, we have to find out. This is our findings. So let us see. I explain you little bit about this cable chart. Cable chart. Let us see cables. These are the cross section of the cable. We have 1 mm, 1.5 mm, 2.5 mm, 4 mm. This 6, 10, 16, 25, 35. There is the current carrying capacity of amperes. They say that if 1 mm cross section of cable, it will carry 13.5 amperes. And if this 13.5 amperes, then it will, for 1 meter, it droppage is 44. This is the MV value, and accordingly this all, this 135 cable, 50 up to 630 cable. This is a single core cables. We have to be note that we have a cables have single phase, single core cables, two core cables, three core, and four cores. So generally we use, if single phase supply, single core cables, we use single care wires, and we can use, and then four core, we have a cables, four core we use. So we go to the next example. We can check the next example. Let us see load. Another example I'm explaining you. Let us consider load as 100 kilowatt. I have a length 100 meter. It's installed on cable tray. It is air. Okay. Then according to same formula we apply. P is equal to root 3 into V into I cos pi. Then we have current. Calculate from this current. Then 100 kilowatt load, 100 into 1000 divided by root 3, voltage 400 or factor 0.8. Then we got the amperes of the IL, load current 180 amperes. Then what is the breaker size? So breaker size, it will be next size of the breaker, that is 200 amperes. We can select the breaker size. It's finish, easy. Next, the complicated, only we have a problem with cable size. Again, apply the same cable size calculation. Then based upon the ADDC standards, you will get 230 amperes. Then if you go for IEC standards, if you buy 0.8, 243.9 amperes. So again, we have to be go back the chart. So according to the chart, we can select it, our cable size as 4 core 70 mm cable size. Now we need to again cross check the voltage drop calculations. Let us see what is the voltage drop, MV into I into L in by 1000. Then voltage drop again 400. What is the 4% of this voltage? It is 400 into 4 by 100. So 16 volts. Then I got the MV value from the chart, zero point 0.6. Then we have 16 volts equal to, then MV value 0 0.6, load current 180, then length I have 100 by 1000. It's now I got 16 volt is equal to 10.8 volts. So we can select the cable size as 70 square. But actual scenario, what is happening, this cable length, I mean, from the sending end voltage to receiving end voltage, we need, our drop should be 4%. Now what is the scenario here? Sending end voltage means you have to be calculated from the transformer, and I mean main dB, from main dB to last load point, your voltage drop should be 4%. Now this, according to these calculations, if you consider this is from MDB to point, your cable is 70 square is enough. But what if it is from feeding from the SMDB, then you have to be calculated from the MDB voltage drop also. So better if you can uh, assume like a 3% voltage drop or 2% voltage drop, then you have to be calculated next cable says 4 core 95. Then MV value you have it from chart 0.45 volts, then you will get 16 voltage is equal to 0.45 into 180 by 1000, 8.1 volts. Better the size of the cables is 4 core 95. Basically these two examples, based upon these two examples, we can calculate the breaker sizes and cable sizes. I can give you a shortcut here. What is a shortcut? I exercises many areas. What I found here, best thing is that if you have a load, like I have a load 20 kilowatts, your breaker size should be multiplied by 2, then your breaker size be 40. If you have a 100 multiply by 2, your breaker size should be 200 amperes. Then if you know the breaker size 200 ampere, this one, then automatically your, you know the breaker size, then there is a chart, I will give you the chart. Based upon this chart you can select your cable sizes up to 100 meters only. After 100 meters apart, then you have to be calculated based upon the same formula. You have to voltage drop, MV into I into L, the same scenario. Okay, see, uh, as I told you, I selected from point A to from where it is coming. This is the, as per, if there is two, if you refer to your material submittals, if open the cable submittal, there is an ambient temperature is there. This is the temperature correction factor or ambient temperature. This have, so this I extracted from the do cap cable again. So what is the air temperature? 25 degrees, my rating is 1.02, 30 degrees 1, 35.96, 40.91, 45 degrees 0.87, 50 degrees 0.82. UAE ambient temperature should be 50 degrees, so therefore I selected 0.82. If you go PVC, what is your sizes? For example, ambient temperature, then 0.71 PVC. If there is XLP, you have to consider 0.82. Similar. Then, as now this another chart. This another chart is, if you there is a MV values as well as current. See, there is a cable cross section conductor 16, 25 up to 500 square cable sizes there. Then if there is a direct in ground amperes, if it is cable is laid on the ground, your it will be, it withstand up to 115 amperes, 150 up. This is the chart. And then single way duct, if you install inside the conduit, then your current withstanding capacity, this one. If it is installed directly on air, then this is your amperes. Okay, like based upon that, according to that same ground, if you install ground, your value this one, duct, your value this one, air, this is your MV values. From this MV values, as I said, then MV value is zero point 0.5 for 95 square 70 square mm, zero point 0.6. This is the MV values. This is the standard copper conductors. There is the values. If you go to the aluminum conductors, there is similar your amperes and MV values. So basically here UAE we are using from MDB to the final DBs, we all use copper conductors. So this is unarmed, this is armored, then there is unarmored also similar. Okay, if you go in detail, what is the current ampere, what is, if you get 19 16 mm cable, consider no, we will take 95 mm cable size, 95 mm consider. So 95 mm, see, current at, this is the current ratings. So this is the voltage drop current. If see this 255, we our cable is 247 something, so I consider like 0.45 and approximately this is, you can consider 0.421 or 0.42. Based upon this chart, you will accurately consider your voltage drops. Then similar 120, 150, 240 is, you know, is all. So there is how I, as I told you, how I can select the cable sizes. You have to be, I check the number of ways. This is the method of calculation, but you have to be by heart this table at any cost. Like a breaker, you have 12. Then if you have a 4 core, you have to use 4 core 4 mm, and 1 core 2 core 4 mm. This chart you have to by heart anyhow. If you, any interview, if you want to go, anyone, they will ask you. They will say load simple. For load, you, they will say you 100 kilowatt load. Then my breaker is 200 ampere. Then my cable size is 4 core 95. Then this you have to by heart. If you practice like this 2 or 3 or 4 times this, with the by heart, you will be get this one. If anyone asks specifically how you calculated all these things, you have to be explain all the basic steps what I said to you. So this is up to now I discuss there is what is the, how the breaker size is calculated, how the voltage drop calculations, all these things I explain you. Now we have I unmute all because I stop here. We have already 30 minutes consumed. I ask you all, if you have any doubts till the date, anyone can, if anyone have any doubts here, you can answer me. Somebody, can you mute somebody like,
Hello, sir.
yeah, yeah, hi.
Sir, you showed now that chart. Now we have to buy hard this
Yeah,
one.
the
Yes.
chat. Yes.
So from where we got these values, the standard values, is it standard or like how it is been calculated for 4 core, 1 core, and CPC?
Yeah, this is the, somebody please, I'm hearing some like somebody put some I don't know, can you mute someone, this I'm hearing the some sounds. See, this chart, basically this chart is how they are prepared. Based upon 100 meters they calculated, same way what we done, same way they calculated. Based upon the calculation they prepare a chart.
Okay, okay.
Okay, yeah.
So but who calculated this? Like from which standard or what is it? Like
See, these standards, you know, like each, we are basically consultants, as well as if you go to the ADDC standards, as well as the DIVA standards, the regulations, they have a charts. Regulation, they clearly mention this is a breaker size up to 100 meters, you select this one. These two standards, you will get this chart. Yeah.
okay, okay, okay.
Standard, see,
Understood.
base, we follow, we are actually electrical engineering. If you go like a point by point how it will become, all by standards. There is, we have like IEC standards, and as well as local regulations. These two we have to consider. Local regulations, we have like ADDC book, we have regulation book, DIVA we have. If you are from India, you have a Indian regulations also there. IEC, IS, Indian Standard Regulations there. These regulations, if you go, they will say to you, this much load, this much breaker you have to take, this much cable size you will be select.
as minimum.
Okay.
Yeah. Any other
If you
questions?
Yeah. Hi, Asif. Kalandar here.
Yeah. Yes, calendar.
Okay. When you calculate, you consider power factor zero point 0.8, whether we have to consider zero point 0.8 or zero point 0.9 and above. You know that we have to maintain 0.93 minimum or 0.95. So when you calculate my power factor zero point 0.8, the current will be very less. So that the sizing of the breaker, sizing of the cable will be very high. So do we have to consider zero point 0.8 in our calculation, or can I consider zero point 0.9?
If you know the power factor exactly what you have to be maintained, you will be consider zero point 0.9. But if it is better if you calculated zero point 0.8, because if you go zero point 0.9, I mean it means it is coming the pure resistive loads coming. If there is our load based upon our load, like if you calculated like a motor loads or something, you will be consider 0.62. Sometime you have to motor load 0.6, zero point 0.7 you have to be consider. And there is a pure resistive load, you need to consider one also. There is only light
No,
load
actually, why
based
I'm
upon the load.
asking, yeah, we are considering power factor correction capacitor in our main MDB. So it
Hmm.
means we are already designing to maintain 0.995 or 0.93 and above. So in that case, whatever my load, it is going to be maintained zero point 0.9 and above. So based on that, so if I consider zero point 0.9, maybe I can reduce my breaker or I can reduce my cable sizing. So is it acceptable this kind of design, or I have to consider as a standard zero point 0.8?
As the standard, basically all consider zero point 0.8. If you, I mean, if you want to reduce your breaker sizes, you can calculate zero point 0.9. The authorities, they will accept. There's nothing much more, because actually the capacitor bank calculation, if forget about the capacitor bank calculation, if there is a no picture of capacitor bank, then actual scenario, as per your load, what will be the power factor coming, this you have to be considered and design this. I mean, in
Okay.
principle, in general, they are using. Yeah.
Mm, mm.
Understand?
Yeah,
Any
yeah, okay.
others, any other
Yeah,
questions?
yeah. One more
Sure,
question.
sure,
This when
sure.
you select this grouping factor, we have to consider 50 degree as by default, and another thing is the method of laying installation you said.
Yeah,
So it
yeah.
will differ, right? Because you are
Yes.
considering 0.82. In another words, you are multiplying it 1.15 times, 15 percentage. So which one ADDC accept? Even simply I can multiply taking 15 percentage higher. Is it okay even irrespective of any kind of installation, or I have to go detailed installation method?
No, see, as per the cable calculation, like you will consider the current for up to the current, this 1.15 from the ADDC regulations. It stays ADDC regulation. But if you go to the ambient temp, because UAE ambient temperature is 50 degrees. All the design based upon the 50 degrees. If your project mentions 40 degrees temperature, then you can select. This is accurate. I mean, this ID is equal to 200 by zero point 0.8. It is. I mean, I show you the slide if you see.
Yeah, yeah, I saw
Yeah,
this. Yeah,
yeah,
yeah.
you see the slide, based upon the 40 degrees you have like 0.91,
0.91.
0.91. From this chart, you will select the your ambient temperature. Based upon the ambient temperature, you select. But I mention here 1.15 because this is from the regulation, RSB regulation books. It says like that. But till the date, I didn't understand. Like DIVA is very clear how it will be calculated. But Abu Dhabi, I'm also, little bit confused. But that's the reason I mentioned the 2 points. Uh, there is no
Uh,
standard in Abu Dhabi.
even though it is indoor, even though it is indoor application, it's completely indoor application. We have to go for 50 degree.
Yes, yes, yes. You are designed 50 degrees. It is, see, it is ambient temperature basically. You know what? It is not from the outside temperature. You are. I mean, it will be one of the factor outside temperature. But when you draw your current, your cable should be withstand up to 50 degrees temperature. You know, the insulation criteria, as well as I mean, you have AC, everything there, but they will be designed 50 degrees. You have to be
Okay.
50 degrees is a basic thing. Your specification
Okay.
says all your design up to 50 degrees, you have to go for 50 degrees. It's all upon
Okay.
specifications. Some I mean UK, they are consider 30 degrees is the standard. They consider
Yes.
if there is some cases it goes to the 38 degrees, depend, but standard as per UK they are maintaining 30 degrees. Yeah.
Okay.
Anything
We have
else?
to go for 50. Okay.
50 degree. I mean UAE it's like 50 degrees. It go better. Anything else?
Okay. Thank you.
Anyone else?
Uh, Excuse me, sir. Actually, I joined late, sir.
Oh,
So can
I'm
you?
sorry. I have to explain you
Sorry.
again. Means I will. You call me. I will explain you in detail.
No,
I'm sorry for
yeah,
that.
no, not details, sir. Only the short, like the here they mention ID. ID current me, sir. Like the
Okay.
you are
Okay.
showing the
See.
example, sir. Load 1000
See. See.
kilowatt.
See. Okay. What I will explain you. Can you wait? Any other questions? I take other questions. Then I will explain you one more time. This thing.
Okay.
So the temperature for which, like, if we
I'm not
select,
hearing.
if we have to,
Can you speak
hello,
loud? Yeah.
am I audible?
Yeah. Yeah. Little bit. Yeah. Okay. Fine.
We, just give me a second, I'll change my earphone.
Still. Can you speak loudly, please? Or you can speak in Hindi if you wanna. I can understand.
Hello.
Yeah. Yes. Now it's good.
Hello, this is
Yes.
Saira.
Hi. Yes.
Actually, I told one shortcut now. Can I
Yeah.
repeat that?
Yeah. See, the shortcut is if you have a load, 100 kilowatt load, multiply by 2.
Okay.
Any load multiply by 2, you will get the breaker rating. Easy. This is multiply by 2.
What about single phase?
Single phase
Asif?
also. Yeah. Single phase also same.
Yeah. No,
You
no,
can.
no, no, no.
I mean,
For single phase, it is different. Single phase, we have to consider, I think, 5.2 or 6.2, the factor, the multiplication factor.
we because as we see here, that any here single phases we consider like a light 2.5 mm basic power, you have 4 mm, if you have AC load 6 mm or 10
Yeah,
mm.
no, no,
This
no.
basic. Yeah.
I agree with you. I agree with you, Asif. Actually, my name is Trimurti Reddy.
Yes, yes.
What I'm saying, now I am talking about the multiplication factor.
Multiplication factor, okay, shortcut you are
Factor. I
saying.
mean,
Single phase,
to
yeah.
carry to to uh, to select the cable size for a particular bracket size.
Okay.
You are saying that if we have like 18 kilowatts load, so we will multiply the
By 2.
18 kilowatts into 2, so it will come to 36 amperes.
So
So the next
next
yeah,
breaker you will
the
go for
next battery is
40.
40 amperes. We go for 40 amperes like this. Whatever you
Yes.
are saying, this is for three phase load.
4 core, yeah. Okay.
As per my as per my knowledge.
Okay.
Yeah,
Okay.
the,
Okay.
the cable, the type of cable will be 4 core. There is no doubt, as it is three phase. But if we want to calculate the single phase, it should be the load should be multiplied by the multiplication factor 5.2 or 6.2,
I will be check
not 2.
again, yani, because as
Uh,
I know that this one. Let me
uh,
check
Yeah,
it again. I will come back to
I
you.
know why, because I know why, because we don't go for this much of deep for single phase. Why? Because we use one single phase for lights, some fire alarm panels like this, or maybe
Yeah,
2.5
yeah,
square or
yeah.
4
You are
square
correct.
cable.
You are correct.
Yeah,
You are
that's
correct.
why we
You are
don't
correct.
go this much of deep.
Yeah, yeah.
Yeah, anyhow, yeah, continue.
Multiply by 5. Yeah, you are correct. Maybe. Yeah, I agree with
Yes,
you. Anything
yes.
else? Hello? Anyone? Any other doubts? Or let me explain you one more time. This one. Khalas, all questions done, correct? Because actually this is a 40-minute session only. I'm looking this one. Why it is recording?
No, also we got one notification here. you are upgraded and the discussion will be unlimited like that. Session will be
Unlimited,
unlimited like that.
very good.
Yeah,
If it is
we got
unlimited,
one.
very good.
Yeah,
Yeah,
no, we
I
got
am
one message
education.
was displayed on the screen.
Ah, really? I've
Yeah.
not seen that one. Anyhow, that's good thing. Okay. Uh, Again, let us one more time. I will discuss with you regarding this one, the one who came late or anything else. See the who came the late. Let us see this one. Yeah, this is the three parameters. One is the IC, circuit load current. IN is the protective device. This is the breaker current. ID is the cable current. These three basic things. IC is load current, means we calculated from the power is equal to root 3 vi cos pi. From that we calculated IC value. Then based upon the IC value, we will be select from the chart breaker current, breaker size. Okay. Then next, based upon the breaker size, then sorry, ID means the cable, how much current it will carry. This is called the cable current carrying capacity. This one ID. So again, the example, if you, I give you example, this one, like a 100 kilowatt load, 100 meters, if you install on cable tray, your power is equal to root 3 vi cos pi. From that I you can calculate it 180 amperes. The next breaker 200 amperes. Then then ID value you can multiply by 1.15 into 200, 230 amperes. Otherwise you can go by grouping factor. This is your ID current. Based upon this one, you have a chart here. You have a chart like this chart. This from this chart, you 18, how much, 247 we came approximately. This is unarmored. Okay, we go for armored cables. Then around your cable will be considered as like a 70 square. Okay, this 70 square you can be select as a your cable calculation. But when you come to know not only cable calculation, you have to be consider voltage drop, whether this cable is okay or not okay. Where it is gone? Yeah, yeah. Then voltage drop, you know the formula, mv is equal to I into L by 1000. From the voltage drop vd is equal to 400. This is 16 volts. This is the voltage or three phase voltage. Then mv value we will consider from the chart, zero. 0.6. Then you will get we have to be see that 16 voltage is equal to less than or equal to 10.5. So our cable is okay. But we will be go for the next cable, because we will be calculate the voltage drop from main db to the up to load. It's the safer side. Hope you will understand. I will be share this what we call presentation with you. Okay. Then okay, we have a time. Then we will be see uh, next scenario as I discussed. There's a next scenario. We have like a MCB. You know the MCB breakers now. What are the types of breakers? You know, MCBs, MCCBs, and ACBs, so on. So we go for final dbs. We have mcbs are three basic types. There is type b, type c, type d. The three types. What are the three types? Based upon the, we know in is the breaker current. From breaker current, this can be withstand up to 3 to 5 times. For we can use type b domestic applications, type c 5 to 10 times of in. Then we can go for commercial and industrial application, type d 10 to 20 times of in. This basically where you need the like tripping characteristics. Based upon that, or how much inrush current to be it will be withstand, so that we will be select the breaker types. Anyhow, next my main consideration is, now we have to be calculated, we have to be tabulated like 1 db. Okay, so let us see. People is load. Now load wattage, we basically load voltage. Let us consider, we have lighting loads and socket loads and water heaters, washing machines, cooker, fridges, motors, air conditioning, xyz. You have n number of things. Okay, let us one by one. What is lighting load? Lighting load we will be consider regardless if you have less than something or something, you will be considered as 100 wattage per 1 point. And the sockets, single socket you will consider 200 watts, and double socket you will consider as a 400 wattage. Okay, then this is again I will explain you later stages, because these all ADDC standards, like a little bit like difficult to understand this one. I will explain you one by one. Okay, next we go to the water heaters. General standards we consider 1500 wattage or actual rating of appliances, washing machine, cooker, fridge, motors. These all, what is the rating you will be considered. This is the thing. Okay, next we have a regulation, as last time who asked me this one, uh, what is the diversity factor. Okay, diversity factor, we know that if we have like 100 kilowatts or 10 kilowatts load, we cannot at a time put this load one time. So I mean we cannot on 10 kilowatts at one time, because sometime light is on, sometime sockets are on, some only freeze. Washing machine we use whole day, 1 hour we use washing machine, or fridge it can be okay, it will be run like a full load, it will automatically. You have to be fridge, you can be considered as a full load, as well as water heater you will use only 1 or 2 times. This how much you are utilizing your load. This is based upon that utilization. The standards, a regulator authorities, they consider, they give one chart. This is called diversified load chart. I'm sorry. The lighting, see, this is they are giving, you have a lighting load. Residential, you have a three type of projects. If you see, residential, villas, this one projects, shops. Okay, shops, stores, offices, schools, mosques, business premises. I mean this is all commercial. This is residential, this is commercial. Commercial you have this one. Then again hotels or some like different projects have different loads. Again, they say one note in ADDC standard, they say that however this is our standards, but according to your utilization you have to be consider your diversity factor. Okay, but in general principle we use, for example, light, it should be on 24 hours. So even though residential you put one, but I'm 100% sure that we are not using 100% lights. So according to the standards, this is the charts. So we go see one lighting, we have a 75 percentage. What is going on? Lighting we have a 75 percentage for residential, and commercial we have 90 percentage, and hotel accommodation we have 90 percentage. Sockets we use very rare, yani in this is the general sockets. In general socket we use 50 percentage and 70 percentage for the commercial, hotels, and 50 percentage. All water heater 0.5 percentage, 0.7 percentage. Air conditioning you consider as should be considered 90 percentage, you have to be considered. Okay, this is the diversified factors. Based upon the diversified factors, you have to be select your load. Again, okay, then I have a load schedule here for one project. uh, Let me give me one moment, because I have to copy where this one. Sorry, one moment please. Cannot be visible. Okay, we go on small db. You are seeing my screen, correct?
Yes.
Yeah. Okay. Okay. See, uh, very small maybe. Okay. Yeah. So, so see, now this is a typical basic load schedule. Okay. The load schedule we have incomer, you have incomer, then you have RCBOs. It's basically Abu Dhabi use, or you can use MCBs in as per Dubai. Then you can use circuit references, RCBOs. What is the what is your phase neutral? I mean, cable sizes is all at cable sizes. Then then you have a load, location, number of points, connected load. These all the basic things, yani. Okay, why it is not coming big? Anyhow, okay. So before this one, I explain you. I can give you how you want to calculate at the you know one enclosure size. Okay, one second. There is a blackboard. You people all know that one enclosure there. Okay, how you want to size this enclosure? There is a formula for this one enclosure to calculation. What is inside the enclosure? Inside the enclosure, you see this one. There is incomer isolator there. This one. Then you have then RCBOs you have. Okay, you have this one, and mm, I don't know how to draw with this one. Black board is there. One second. Okay. See, you have like one dB. Okay, this is your dB enclosure. To calculate this dB enclosure, see, I explain you any basic thing. Okay, don't go any standards. This is your incomer. Okay, your incomer here, incomer. Okay, my writing is poor because I'm writing with the mouse. So you have like Abu Dhabi, you have a standards. You have two types of ELCBs. For lighting, you have 30 milliampere and sorry, power you have 30 milliampere, and lighting you have 100 milliampere. These are ELCBs. Then you have like R, Y, B. Then again you have your MCBs. These all MCBs. Then you have here your neutral section. Then you have here earth section. Okay, this general if you notice how the db it is look, you need incomer, then you have elcbs, then rcbos, this one. But Abu Dhabi you have a standard like 40 40 40 centi width. Okay, width you need like 40 width. These breakers, according to the breaker sizes, your incomer is designed. But like Dubai, there is like uh, you know you have like two rows dbs. Okay, two rows dbs and four rows, dBs, 5 rows dBs, 6 rows dBs. You hear this one. How we will get these rows? This is the main calculator. So number of rows. This is the formula. Number of rows of breaker. Sorry, number of rows is equal to. Sorry. What is the pen? My God. Okay, number of rows is equal to total number of modules. Okay, total number of modules by each row how much module. Yani, I mean number of mod total number of modules divided by we can say like each row module. Like you have a one row, it is one row, you have a 16 modules, okay, or 12 modules based upon the breaker. Okay, sorry, some type of standard breaker manufacturing. So you have like consider this 16 row. So number of rows equal to total number of modules by 16. You will get the how many number of rows breaker you need. How we will get this total number of modules? So you will see this one. Number of incomer you consider the 4 modules. ELCBs also you consider the 4 modules. MCB you consider 1 module. Like timer you will consider 1 module. What is a module means? See, basically if you see this one, the breaker sizes. If like you you will generally you will consider like 4 modules. This one as size you have it like I will give you this one also in the presentation, but I forget this one to add the slide. That's why I draw this one. Okay, anyhow, let us again go back to our screen. So we here basically Abu Dhabi or Dubai, we use mostly lighting. You need to use a 2.5 kilowatts, sorry, 2.5 mm wire. Power you use the 4 mm wire. As I said before, AC you use the 6 mm wires. You have to be use it. This is the standards. Again, basic. If you go to the basic, one circuit. What is one circuit load? One circuit load, as per the international standards, it is 1000 watts or 1200 watts. But you can keep up to, I mean, this is the standard basic one circuit means 1000 watts or 1200 watts. So UAE up to, I mean, Dubai standards, if you can see 1000 kilowatts or 1200 kilowatt hours, you use the 10 ampere or 16 ampere breakers. And if you go to the 2000 watts, sorry, 1000 or 1200, you use a 10 ampere breaker. And if you go to the 2000 watts, you can use a 16 ampere breaker. There is a ring circuits, you have to use the 32 ampere breakers. These all standards. Based upon these things, according to the load, you will be design your what we call design your distribution board. So again, uh, Abu Dhabi, to be frank with you, I don't like Abu Dhabi standards. Anyhow, they have like, only for power you have other DBs, you have light, you can have other DBs, or sometime you can mix up. So this is the power DB, this PDB, this power DB. So this DB have all RCBOs. What is RCBO rating? I mean leakage current rating, 30 milliampere. This is the RCBO ratings. How we get these ratings? Again, this load based upon the connected load. Based upon the connected zero point 0.5 kilowatts, you selected 20 ampere, because this is not, I mean, what we can say, based upon the our specification. This is my project load based upon our standard specification. According to the IFC, it's mentioned 20 kilowatts. You have to be considered 20 kilowatts. This is the reason they are considered here. So not required 20, if a 0.5 kilowatt, you have to be consider 20 ampere breaker. It can go consider 16 ampere also. Okay. So see, anyhow, let us see one point. What is the point? What is the load? Then you have to be balance your R phase, Y phase, B phase loads. According to that, you have to be arrange your cable sizes. This is the diversity factor. Again, we check that chart. Based upon the chart, you can provide your diversity factors. As I said, these diversity factors varies from according to your applications. How much percentage application this is used. This is you can suggest. This is agreed between you and ADDC regulations. You can agree, or if there is a only residential based upon the chart, you can provide it. Or according to our project, we provided it this based upon the point 0.7, the load coming 0.35 kilowatts. Okay, okay. So uh, what we can say, you will calculate it all this one. Finally, you know, R phase this much kilowatts. Then you will get diversified. He will apply 0.75, 7.56. So total connected load 10 kilowatts, diversified load 7.56. Halas. Based upon 10 kilowatt, you will check. You will select the your breaker ratings and cable sizes. I mean, I'm little bit hurry, so sorry for that. If you have any concerns here, you can ask me. We can explain you a little bit more, because you know I explain you the how you basic. This is chart. This chart. I mean load schedule. You can prepare by yourself. It is not big task, but basic important thing. You how you will be choose your cable sizes. How you will choose the breaker sizes. This is the reason I stress those two topics more. Okay, you have anything else, you can ask me here.
So you will be sharing this file, Excel file.
This Excel file, you need this
Yes.
Excel? Yeah, okay. I mean presentation I can share with you. Yeah, sure, I can share with you Excel sheet.
Presentation and this and the whiteboard explanation.
Whiteboard explanation, I will add that
This
slide. Actually, I will add that slide, like how much, how you calculated the enclosure sizes. I will add that one.
okay, fine. With that and this Excel and that PPT.
Sure, sure,
Okay,
I
sir.
will share.
Thank you, sir.
Okay, thank you so much. Anything else?
Yeah, Asif,
Mm.
when we are
Yes.
talking about selection of cables,
Mm.
I mean size of the cable,
Mm.
uh, we did well. I mean calculation up to the calculation, but see when we go to EDTC regulations, they are saying that in case of designing the SMDB incoming cable size, we depending on what base we are selecting the cable size. I mean, connected load or diversified load. Uh, do you
All,
get me my? Do you get my point? What
yeah,
I'm
you need
asking?
the cable
What?
sizes. Cable size.
What I'm asking?
Mm.
See,
Again,
for a
selection
final
of
DB,
SMDB. Okay, final DB.
yeah,
Okay.
for a there is on final DB. It has the load, the connected load of that final DB is for suppose 24 kilowatts,
Okay.
right? It
Okay.
means 24 means 48
Okay.
amperes. 48 amperes is coming. For 48 amperes, the incoming breaker size will be 63 amperes.
Okay.
For 63 amperes breaker, we take
16.
16 square mm cable
Okay.
as the minimum.
Okay.
Then uh, up to here it is okay. For suppose if we take 5 final DBs,
Mm.
all these final DBs are feeding by one SMDB.
Okay. Agreed.
Now the SMDB connected load is for suppose let us take 24 150 150 kilowatts.
Okay.
24 kilowatts to like that, 150 kilowatts.
Okay.
So when we consider the diversified load of this SMDB, the connected load of the SMDB is 150 kilowatts,
Okay.
and the diversified load of the SMDB will be less, maybe 100 kilowatts or something, 120 kilowatts like that.
Okay.
To select the SMDB, incoming cable size, which load we are going to take. Why? Because I think ADCC regulations are suggesting that we need to take diverse load when we are going to select the assembly incomer cable size. So are we following this in practical design of projects or not? What I
yani as
did,
aware
did I think I took more time because our participants also can understand what I'm telling. That's why I took a little
yeah,
bit
it's
time.
okay, it's okay,
Yeah.
it's fine for me. I don't mind it.
Oh.
The basic thing, as I know that you have to be, this is a regulation only, you see. This regulation, the RSB, as I explain you, this is like
Mm.
very, I mean, um, what I can say that RSB I didn't understand much, because it
No,
is
no
all,
need.
I will tell you, I will tell you, I will
No,
tell
give
you.
me I
Let
mean
me complete.
short answer.
Yeah.
Are
Short
we
answer,
are we
short answer
are we,
is a design. Short answer, you have to be cable sizes should be considered for full load. It should
based
not
on
be
the connector load, full
based
load?
upon the connected load. It's never,
That's it.
because if we don't know, I will on all the load one time, so I have to be damage my cable. No, I should not damage my cable.
Mm.
So
Mm.
in order to that one, I will be consider, I will use
Only
full
total
load
connector load
cable.
of
Yeah,
the
yeah, as
distribution
per
load.
the design, yes,
Mm.
I can use this
Mm.
one.
Mm.
Then I have a voltage drop also, you have to be considered. This also have
Yeah,
a factor,
yeah,
you know.
yeah.
Based
Yes, yes.
upon this voltage
Mm.
drop calculations, as well as the load, connected load,
Mm.
these two factors we will consider. But similarly, I'm telling you, as per the ADDC clearly says, ADDC as per RSB regulation, if you open, you see this one as my slide, you're seeing my slide, correct?
Mm.
Yeah, this
Yes.
slide is saying that the cable current, it should be greater than the breaker sizes, it should be
Mm.
greater than the load current. This
Mm.
load current, where as per the ADDC, load current is total connected load only. It is not saying the
Mm.
diversified load current, diversified load. No, you, because your cable, yani when it's, again I'm telling you, here two things are you have to be considered. We as a consultants, we design for the full load. Our cable is be basic for full load. But now again, Dubai is very clear. Total. They will all design on the total load itself,
Mm.
regardless,
Mm. Mm.
regardless diversified load, because they need to know they are all basically transformer sizes up to MDB. They will all consider connected load only, because this is more accurate, more
Mm.
practical, also more practical, more accurate. And if you want to, that these all diversified load, because they want to calculate the transformers, how many transformers we have to be put. Only transformer they provide on the diversified loads only. If you
Mm.
want to you want to save money, it's up to you. You want to save money, or you want to save cable sizes, okay, then you will be consider diversified load
Mm.
only. What will happen, if you see the breakers, if you, I will show you. There is our projects, we have future loads. So
Yes.
we have future loads, we have a spare loads. And sometimes this one socket means, if you see nowadays, if one socket means you're not using 200 watt, is it not using, they are using more. I mean, you will be
Mm.
connected for one socket, you will use as a four socket, it is not applicable,
Yeah,
but I'm
by
telling you. So
yeah,
you
by
are,
using extension cables, right?
yeah, you are using extra load.
Extension boxes.
So better, the main important criteria, cable, your cable should not be damaged, your
Mm.
should not be
Yeah,
overheated.
yeah. Finally, you are saying that it is safer to
Safer
go
is
for connector
connected
load.
load.
That's it.
Yeah, this is
Mm.
my opinion. As a consultant, we will design this one. But
Yeah.
you know that you work like ADDC projects. So this ADDC is different. You submit something, they will approve something like that. I
Mm.
I
Mm.
am very, like, I like to work in Dubai, because it's very clear there. This hope.
Mm. Mm.
Anything else?
Thank you.
Welcome. Anything?
So, what topics shall we know? What topics we are going to cover in the next video? Or
Yeah, next week we, yeah, you have to be tell me, yani, what you like to know. So
yeah,
then
they see
accordingly,
how So far you covered how we are designing and I mean for up to finally we everything.
Okay.
But how we,
Okay.
what is how we decide the transformer side? Is
SMDB
it yeah,
transformers.
is it in our I mean is it in our hands or LEDs will decide? Or if we are designing how we are designing the transformer side
Yeah,
like that?
yeah,
What
yeah,
is the
yeah.
capacitor bank size?
Okay, okay. I will
This
cover
type
up
of
next
topics.
topic, transformer sizes and capacitor banks, as well
Mhm.
as what is the key points
Other,
to be considered.
other things if it is possible like generator size calculation, UPS
Yeah,
size calculation,
yeah, yeah. Okay, I will do that. I
these
will do
things.
that. These things, but
That also
basic
like CCTV and all.
CCTV you need.
CCTV will go on for
Yeah,
This
we
public
PLD
addressable.
system.
no need.
Yeah.
Yeah, it is all. You know the
Okay.
power and light. You're very good. I'm sorry. No, what I'm trying to say. Let us first of all focus on
Yeah.
our basic core subject. If we know,
Mm,
we will cover all these topics. Once we done, then we will go again one by one step. All low current systems we will be start. I mean, you got it. You got my point. Because
Yes,
we
yes,
have
yes.
in the
yeah.
power, we have many things. Now
Many things.
only
Yes.
we know only we calculated the cable sizes and the breaker sizes. Only we calculated these two things. Now we have to size the SMDB and how many outgoings based upon how many required. How you calculate the SMDB, then transformer MDBs. What are the MDBs? If there is a if I can explain you, there is a switchgear, plenty of things we don't know. Still we don't know, because as per me, I thought that I know better, but when I come to know some things, I don't know. I'm know only 0.1% or 0.1%. You know what? You have to be how you will calculate your cross section of the bus bar, how you will be selected, what is. I mean, we are all depend upon the supplier. No, there is a IEC standards there. Its standard says that what you have to be look when you want to test the SMDB or MDBs, what you will check in MDBs,
Mm,
what are the key things you have to be check while you are go for factory test, or you want to review a MDBs. Okay, what you have to review, what is the form 4 types, how segregation is there, what is ambient temperature, what is a big lot of things there. And in detail, if I go in detail, there are a lot of things still we don't know. So first we focus basic things, we focus like calculations, we focus first initial sections, go one by one, it's easy for us. We cover up all power, then we will start low current, because low current
mm.
I'm not very well but
I know,
I
I
will
know.
I will
For
do that.
a design section
Yes, yes.
for
We'll
low
cover
current,
this
there
first.
will be one in like that.
Yeah,
Yeah.
yeah. I will try to cover all these topics and one by
Sure,
one,
sure, sure.
so that it's easy for us to access. Yeah.
Yes.
Anything else? Because last
Nothing. Thank you,
presentation,
sir.
yeah, last presentation, this presentation I will share you. Yes. Anything else? Okay. Last presentation and this presentations I will share with you soon. Actually, I'm summarizing the things because I don't have time. Anyhow, I will share you soon. Okay.
Yes, yes, sure, sure. Thanks.
Thanks so much, you all.
Thanks.
Okay.
Thanks.
Thanks so much.
Okay.
Good day.
Thank
Bye
you.
bye.
Thank you so much.
Bye. Where is this? Okay. Stop share.